Hi friends, my name is Kumar, and this video is about VPC. So the objective of this video is not to go in depth of VPC, but this video is just to help you guys to complete the practical steps while setting up the VPC. We'll be covering the basics of VPC, and my main focus will be on the implementation steps uh, for setting up a VPC environment, right? Okay, so let's begin, and we'll start with some slides and then we'll move to the practical session. So, what is VPC? Now, VPC is, as the abbreviation is VPC, so it derives virtual private cloud, and you all are aware that AWS is a public cloud. So you are setting up your own private cloud, or you can set up your own personal network, and within that network you can create your resources and you can work like it is your own LAN. So it's a virtual network dedicated to your AWS account and is logically isolated from other virtual networks in the AWS cloud. You can launch your AWS resources such as Amazon EC2 instance in your VPC, and you can totally customize your VPC in terms of IP address range, in terms of number of subnets. You can set up your own configuration. You can set up your own routing tables, network gateways, and security settings. So this is a generic scenario where the diagram itself is showing you that inside the region, AWS region, you are setting up a VPC, and the network range is 10.0.0.0/16. Now the thing to note here is you cannot create a bigger network than /16, right? And within this VPC, you are creating two subnets. One is called private subnet and one is called public subnet. So why we are saying them private subnet and public subnet, and why there is a need of two different subnets. So you might have heard about a three-tier architecture application where we require a web server, and in backend we require an application server and a database server. So assuming that kind of infrastructure, your web server should always be public facing so that people can access the websites. But I don't really want my database server or my application server to be public facing. They are they are actually required by the web servers but not by the end users, right? So to make them secure, I would always try to hide them from public. So I don't want them to be internet facing, and I don't want unnecessarily people access them. So I have created two different subnets. One is called public subnet. I'll launch my web server in public subnet and it will be public facing. And the database servers, I'll launch them here in the private subnet. Now, what differentiates between the public subnet and private subnet? Now, this is the internet gateway through which you will be accessing these subnets. So, a public subnet will the machines in a public subnet will access internet through this internet gateway, right? So, uh, to access the internet, we have to also set up a routing table so that all the machines in that subnet can point their traffic towards this internet gateway. And by default, the machines or the resources in these subnets, they can interact with each other without any issues through this router. So we need not to make any additional efforts to make these machines interact, right? So this diagram looks little complicated, but we can simplify it using some step-by-step instructions, like how should I set up my VPC. So what we'll do, I'll just draw the steps as how we need to do the lab today. So what we are going to do is we'll be creating a VPC. So our first step will be to create a VPC. And then, okay, but before we go to the steps, we need to understand what exactly we are trying to achieve. So we are trying to achieve like we want to create a VPC with two subnets, and one will be a private subnet and one will be a public subnet. We'll be launching a web server in the public subnet, and we'll be launching a database server in the private subnet. And will ensure that the web server is accessible and the database server is not accessible through internet, but both the web server and application server, they can communicate with each other, right? So this is what we are trying to do. So for that, we'll be doing it in steps. So the first step will be the first lab sorry the first lab will be uh, set up a VPC with public subnet and launch a web server there. All right, let me enlarge. Okay, the next uh, lab will be to set up a private subnet in the same VPC with a database server. Okay, all right. So in order to complete the lab one, we have to do a we have to create a VPC first, and then within that VPC, we'll be creating a subnet, and then we'll see what to do next. So we'll go step by step. All right, so I'll simply go to the AWS console, and when I click on the VPC service, I get a dashboard for VPC like this. Now there are two different ways to set up your VPC. One is you can get the VPC widgets and you can simply create a VPC. So there are four different scenarios. But the thing is, doing this way is very simple. You have to do nothing, but you have to just specify the IP address ranges, and rest everything, all the components of VPC will be created by AWS automatically. In this case, maybe your learning will be less, but yes, your work will be easy. So what I suggest is, let's not follow the VPC widget, and we'll try to create each component of VPC one by one, so that the understanding is better on each component of VPC. So the first thing we'll be doing is we'll simply we'll go to VPC dashboard, and we'll create a VPC here. So we go to your VPCs and simply click on create VPC. We have to assign a name tag. So let me just give a name called demo VPC, and we have to give a IP version 4 CIDR block. So CIDR block is nothing but it just represents your network. So as shown in our picture, I just presented a while ago, we'll simply create a VPC network called 10.0.0.0/16. Then nothing else. Tenancy will be the default, otherwise it can be dedicated. So I want a shared tenancy only. I'll go and create VPC. So once the VPC is created, I can verify it. So this is our demo VPC. This is the VPC ID. State is available. This is the network for which I'm setting it up, and few more details you can see here. So as you created the VPC, by default a routing table is created and a network ACL is created. Now let's move to our next step. So our next step is to create subnet. So we'll be creating a public subnet. So come back to subnets, and so there are already two subnets there. Now we have not created them. So by default, when you create your account, you get a VPC created for yourself, and the default VPC has these two subnets, so we are not going to touch them. We'll create a new subnet for ourselves. So tag, we can give a tag so that we can identify our subnet easily. So I'll make it demo VPC public subnet, so it will have a better understanding. Okay, and then availability zone preference. So you can associate or you can like link your your VPC subnets with the availability zones available, so that whenever you will choose a subnet while creating a resource, uh, that resource will automatically be created in that particular availability zone, right? So let's choose any one of them, AP South 1A for the public one, and we'll specify the network range for our subnet. So let me choose slash 24 10.0.1.0.24. Yes, create. Okay. Now once this subnet is created, let's see, this is the subnet created. Okay, and it is part of this demo VPC. Now what is our next step? Next, if you see that diagram again, let me just present it to you again. If you see this diagram, we have created the VPC and we have created the public subnet. Now next step is we have to create a internet gateway, and the internet gateway needs to be attached to that VPC. Okay, let's do it. So we'll be creating a internet gateway and attach it to VPC. Let's do it. So in the dashboard, you will find internet gateways. Okay, there is one which is already there, so we'll not touch it. We'll create our own internet gateway. Just a name tag. I'll give demo VPC internet gateway. So demo VPC internet gateway, create. All right. So this is the ID and this internet gateway is created. So here I see this demo VPC internet gateway is created, and this uh, this gateway is showing itself as detached. So what we need to do is we have to attach it to our VPC. So go to actions and attach to VPC. Done. Now attach to VPC, attachment to a VPC. So here is showing the VPC name. I have selected it, and I'll not do it with command line interface, so I'll just close it and attach. All right, so now my internet gateway is attached to the VPC. Now what is the next step we need to do? Next is we will be launching an interface, we'll be launching an instance in this public network. So let's do it. Launch a web server in public subnet. And once the public subnet is launched, we'll move to the next step. So I'll let you know very shortly. So now we'll go to a service. Sorry, I'll close it, and here is EC2. Open a new link. I'll go to EC2 and we'll try to launch a server here. Okay, so launch instance. I hope you guys are aware about launching an EC2 instance. I'll not go in detail. I'll rather quickly launch one instance. So the only thing here to mind is this network. Here we need to select is demo VPC, and since we have only one subnet, so it is showing me one subnet only, and then auto assign public IP. So there are three options there. Either we can forcefully enable it, so by default the machine will get a public IP, or we disable it, so it will not get a public IP, or we can leave it to the subnet settings. So if it is enabled for the subnet, the machine will get a public IP. If it is disabled, it will not get it. But since it is a web server, it should be public facing, and without a public IP, it cannot be public facing. So we should rather leave it on the subnet, and since it is a public subnet, so the public subnet should be able to assign a public IP. So we'll select the subnet, go to the actions, and modify auto assign IP settings. So enable auto assign public IP4 address. So once done and once refreshed, you will get it use subnet setting enabled. So we can mention this in a step so that you don't forget while you do the practicals yourselves. So create subnet and enable auto assign public IP. Cool. Okay, so now by default the machine will get a public IP, and then tendency nothing else. Just one thing, I just don't want that machine to launch first and then I'll be doing practicals. Rather, I'll put it in the in the launch script. So uh, I guess you guys are aware about this, that at the time of launching an instance you can specify your commands like a script. So I have mentioned shebang, which has been bash, and then I can specify my commands here like yum install httpd. So automatically these commands will run and the web server will be ready for you. So yum install httpd, and then I want to create a web page for you. So this page is presented by, and I'll say uname minus n. So redirect this to /where www html and make this page as index.html, and we'll start the service. Systemctl start httpd dot service. So these commands will run automatically. No additional storage is required. Name tag we can give here name, and the name is web server. Move next. Security gateway, it's very important. So we can create our own security gateway here as a security group here. I'm sorry if I said security gateway, it's security group. So create a new security group, or you can use the existing one. So better we create our new security group. So I'll give it a name demo VPC security group, and the security group is also for web. Okay, yes, let it be web. We can change it if required. The same description I'll mention here. Copy and paste it. Now, since it's a web server, which all ports we need to open? I want to open what? So we need to do it again. Something is wrong with my browser and my mouse. I'll just repeat the steps quickly. Select next. Selected my VPC. Enabled. Yes. Network interface not required. Pin bash. Yum install httpd -y echo page is presented by uname -n, redirecting it to /where www html index.html, and systemctl start httpd dot service. That's it. Next, add storage tags, add tag name web server, demo VPC web security group. I'll mention the same here. as description demo VPC web security group. Which ports I need to allow? SSH and HTTP. Okay, and also if you want to check the server with the ping response, you also need to enable ICMP, and I want to do it from anywhere, so I selected anywhere. Review and launch. Now I'll go with an existing key pair, so I'll use Tomcat. This is a key which I created earlier. View instance. Okay, so the instance is being launched. You are seeing the instance state is pending and it is still initializing, but we have already got the public IP for the instance. So one way to test is we can simply use the public IP and we'll see if there is a page opening. So http colon slash slash and the IP address. It's taking time. The site can't be reached. Okay, so if this is not coming up, you have another option to test, which is your putty. So we'll use putty to access this. So I'll use the public IP and I'll browse the SSH key out. We can see what's wrong with the server. I'm not sure if the commands we specified ran or not. So we can check that. All right, we cannot. Now you guys need to think like why I cannot access this. So somewhere we have done a mistake and I have done it knowingly, so that you can come to know what are other VPC steps we are missing. So our server is actually not accessible. And now come back to our VPC diagram and see what we have mistaken. Okay, so what we are missing. So we have created the VPC, we have created the public subnet, we have created the internet gateway, but we didn't specify the routing table. So the traffic in this subnet is actually not pointing to this internet gateway. So that is the reason you cannot access these machines in the public subnet. So one thing which we need to do next is we have to we have to create a routing table like this, and this routing table needs to be associated with this subnet. And once associated, you need to direct your all traffic towards that internet gateway. Sorry guys. So let's do those steps, and accordingly I'll mention them to our steps. So create a routing table, associate with the public subnet, and direct all traffic towards internet gateway. Go ahead. So uh, come back to our VPC console, and we'll go to routing tables. Here we'll be creating one, or we can modify the existing one. So I'll create a new one for the public subnet. So I'll say a routing table public subnet inside the demo VPC. Yes, create. Okay, so this is a routing table. Now next is create we need to create a rule here, so that all the traffic in the subnet What is a subnet? Subnet is already okay. Subnet will be associating, but we are pointing a destination here that uh, every traffic should move towards this internet gateway. So as soon you click here, you will get the list of internet gateways you have in that VPC. I got the internet gateway and I selected it and saved. Once done, we need to associate this with a subnet. So I'll click on subnet association, add it, and I'll select our public subnet. Click and save. Okay, so the routing table is now associated with your public subnet, and we'll go and check if the website is accessible now. Still not. Okay, let's check again. Okay, so this is our public IP, and I'll also try to see if we can access it through PuTTY. So open PuTTY, the IP address of our web server, auth, browse, open, and here we go. I got EC2 user logged in, and let me see what is the status of our service. Oh, httpd.service could not be found. That means something wrong happened. Okay, obviously something wrong will happen. The reason being, at the time of launching the commands, the server could not install HTTP. Why? Because at that time the server was not able to access internet, right? So if we would have done this step before, the HTTP would have installed automatically. If not, we can do it now. So yum install httpd -y. Okay, so all the packages are installed, and next we need to create a web page. So the same thing I'll write here. Page is presented by uname -n. It will print the host name of the machine and redirect it to /var www.html/index.html. Done. Systemctl start httpd.service. Done. And check the status of the service. All right, and try to refresh the page again. Here we go. So the page is presented by IP this. That means this is a server. If you see again, what is the host name? Sorry, uname. It's uname. Yes, it's the same name. So that means the page is coming from the same server. So this was our lab 1, which we have successfully completed. So let's see the steps again, and let's revise what we have done. We created a VPC, we created a subnet, and we changed the settings so that it can assign the public IP automatically. We created an internet gateway and attached to the VPC, and we launched a web server in our public subnet, and we created a routing table associated with the public subnet and directed all traffic towards internet gateway. So if you swap these two steps, you will not have to log in on the server manually, and you have to create the uh, you have to install the packages and do the rest of the steps. So you can, if you want, you can actually swap these tabs so that at the time of launching the instance itself, your packages can be installed. Okay. All right. So what is next? In lab 2, what we'll be doing, we'll create a private subnet and then we'll launch a database server inside it. So the public subnet is done. Now we'll create a private subnet, and inside that private subnet we'll launch a machine and we'll install MySQL on it. Okay, so let's do it. So come back to our VPC console, and here we'll go to subnets again. We'll create a new subnet. We'll give a name called demo VPC private subnet. So this time I'll select the other availability zone, which is AP South 1B, and the network block will be 2.0/24. Yes, create. So the new subnet is created. It's still creating. Yeah, created now. And now we'll go to our EC2 console and we'll launch a new instance in the private subnet. L7. Okay, so network demo VPC, and this time I can see two subnets. So I'll select the private one. And you need not to assign a public IP. So we didn't make any changes to the subnet settings, and let it be disabled. That's it. Nothing else. Add storage tags. I'll give it a name called DB server. Okay, now to the database, what all I need? I want SSH from anywhere, or you can specify if you want from a specific IP. I also want to enable ICMP. Okay, anywhere. I also want to allow MySQL port. So MySQL, it runs on port 3306. Done. Review and launch. I'll use the same SSH keys, which is Tomcat, and done. Now, now, now you will see that the database server is being launched, and you will not find a public IP assigned to this database server. So how will you access it? How will you access it? You cannot access it through your Windows machine now, because we are on internet and there is no public IP, so we cannot access this machine without a public IP. So what next we can do is we can like if you see the diagram again, and if you remember the points I said, any machine between these two subnets, they can interact with each other without any additional efforts, because they are all interacting through this router, right? So if we cannot SSH to the machine in this subnet from our Windows machine or from our personal computer using the AWS console, we can at least go to the web server, and from that web server we can SSH to this database server, right? So what we can do is we will copy the SSH key to the web server, and from that web server we will SSH to our database server. So let's do that thing. So first we need to get the SSH key here. For that, I'll use a tool like WinSCP, and then I'll get the SSH keys there. So let me do it. I have, or if you guys don't even know how to access WinSCP with SSH key, I'll just share that also with you guys. Okay, so SSH, I'll be requiring the IP address of my web server. I'll select it, copy the public IP, go to WinSCP, host name, you can put EC2 user here also, go to advanced and advanced SSH authentication, browse the private key, so we use Tomcat itself, done, login, yes, permanently copy, here we go. So we got this side I have this uh, my Windows folder structure, and this side have the home directory of EC2 user. So I'll simply drag and drop the key, and then I'll do the SSH. So I'll go to this knowledge base. I have to find it. Here it is. So simply, okay, one thing. Now tomcat.ppk is required for putty, but if you have to SSH from one Linux machine to another Linux machine, the .pem keys are used. So we have both tomcat.pem key, which was downloaded when you first time generated this key. So I'll use the same tomcat.pem and I'll copy it to the Linux server. So let's come back to the web server, and if I come back to EC2 users home directory, I can see it here. So tomcat.pem is there. The only thing to mind is the SSH PAM key. It works only if the permission for the key is 400. So I'll change it to 400, and now I'll use this key to SSH. So SSH minus I, specifying the key, and then I'll specify the IP address, which is the private IP address for the database server. That's it. So it's asking to copy the the RSA key permanently to non-host file. I'm saying yes. Okay. All right, so now we are on the database server. If you see, the IP address here is 10.02.15, to which we SSH'd. So now I'll become root, and here we go. So this is, if you want, you can set up a host name to this machine like this, DB server, and permanently you can do it, etc host name. All right, so Vim is not there. I'll go with VI. I'll comment this line, and I'll put the host name as DB server. Though it is not required, I just did it. Okay, so now we launched a machine in the private subnet. We created a database server there. The database server is not accessible through internet, but it can be accessed through the web server because both of them are in the same VPC. Now what next? Our second lab is completed. Let's see. Yeah, our second lab is completed, which was to create a private subnet with a database server. So what we did in second lab, we create a private subnet. Second, nothing else we did. So we simply launched an instance in private subnet, and copied the SSH key, copied the SSH private key to the DB server, sorry, to the web server. From web server, SSH done to the database server. So good. So we have done both the labs, but there's one thing. Let's come back to our diagram again and see if we are still missing something. Yes. There is one more stuff there that is called net gateway, and there is one more thing which is called elastic IP connected with this net gateway. So what is a net gateway? What is net gateway? Now, net gateway is required when your machines in private subnet they need internet access. For example, this database server, if I have simply launched this machine called database server, but suppose if I have to install the RPMs for database, let's say I want to install MySQL. So yum install MySQL -y. Now this thing will not work. Why it will not work? Because the yum repositories they are actually pointing to some mirrors on internet, and this machine cannot access internet, right? So if this machine cannot access internet, this machine cannot install any RPMs on itself. So for such requirements, we have to assign or we have to give internet access to this instance so that such requirements can be fulfilled, right? Now you need to keep in mind we are allowing internet from this machine, but we are not allowing anybody from internet to access this machine. So it will be one side internet access from the server to internet. It's not from internet to the server, right? So for this purpose only we require a net gateway. So let's do this thing. We'll create a net gateway in our VPC, and the only thing which you need to keep in mind while creating a net gateway is it always need to be created in the public subnet. So let's go net gateways, create a net gateway. Okay, now select the subnet. Now as I said, the net gateway needs always to be in the public subnet. Now we are not able to identify which one is public, so I'll go back and I'll see which subnet is public. So go to VPC again on the dashboard, and I'll go to subnets. So this is a public subnet and the ID is CE6F. Okay, now create the net gateway. Create net gateway CE6F. This is the subnet ID for public subnet, and the net gateway requires a elastic IP. Now, if you don't know elastic IP, again it is a static public IP which is detachable from one resource and can be attached to another resource. So it's a static public IP and it can be moved from one instance to another instance if required. So the net gateway requires elastic IP. If we don't have one, we can create one. So create new elastic IP. It is created and it automatically selected it. So this is the new elastic IP. Create a net gateway. Okay, now what next? The net gateway is created. Done. And it is showing pending. So okay, it'll take some time, but meanwhile what we need to do is, let's see. So next step is I'll create a net gateway, which we have already done, and then uh, we need to create a route table for private subnet and direct all traffic towards the net gateway. Okay, so go back to routing tables, create a routing table. We'll give a name RT private. Okay, whatever. So routing table for private subnet, and it will be the same demo VPC. Yes, create. Okay, so the private subnet routing table is created. Now we'll set up the routes. So now what we want, traffic for any destination, it should it should move through this net gateway. That's it. Okay, so the route is done, and now this this routing table should be associated with our private subnet. So I'll select the private subnet and save. Done. All right. Now let's see what is the status of our NAT gateway. It's still showing pending. Okay, now it is available after a refresh. Now go back to our database server, and from here let's try to install MySQL again. Will it work? Okay, rather we can also try if we can access internet. No, we cannot. Why? Let's see where are we mistaking. So I'll leave it aside. I'll see what wrong we are doing. We have this NAT gateway. This NAT gateway is connected with, oh, this NAT gateway is connected with the public subnet. Why? It should be connected with the private subnet. One second. A NAT gateway should be associated with, oh no, it's not about association, it's about where we have created it. Monitoring is not required. Okay, so NAT gateway is created. There is elastic IP associated with it, and then come back to um, routing tables with the subnet. So where is the subnet? Private subnet. It has a routing table. Oh, same mistake. So why /16? We have to make it. Uh, we have to make it 000. So go back to routing tables and edit it. Let it make 0. Okay, and now where is our putty session? Yeah, it immediately started pinging. So now it can also install MySQL. Yes, here we go. So guys, small mistakes we can make. So we have to be little cautious, and we should be aware about the basic concepts so that you can correct if such kind of mistakes are done. So now our third scenario is also completed. We have created the NAT gateway, created a routing table for private subnet, and directed all traffic towards the NAT gateway. And this way we can install ARPM, right? So this was setting up the VPC, and if you want to see the diagram again, here it is. So we created VPC, we created two subnets. One subnet is public, one is private. We launched a web server in public subnet, launched a database server in private subnet, and both the machines can interact with each other. The websites are publicly accessible, but the database servers are not. But still, the database servers uh, can give the feeds to the web servers, and this is how the VPC is set up. So we are done. I hope you enjoyed the session, and this will help you to make the practicals for VPC. Thank you guys. Thanks for watching the video.